session, we are all going to learn what all about the non-parametric test. What are its methods? So let's begin with the brief introduction about the non-parametric test. Non-parametric tests are actually the mathematical methods which are mainly used for the purpose of statistical and hypothesis testings, which doesn't belong any assumptions about the frequency distribution of any of the variables that are actually needed to evaluate. These tests are actually termed as experiments which are being used when there is a skewed data, and it also includes all of the techniques that do not depend on any of the data, which actually deals to any sort of distribution like normal distribution, Poisson distribution, or the binomial distribution. And that's why, in other words, we can call the non-parametric test as a distribution-free model where such test doesn't belong to any type of distribution like normal, binomial, or Poisson distribution. The word non-parametric test does not mean that these model does not have any parameters. Of course, they have a parameters. Of course, they have a procedure to calculate the value of mean, median, but using a specified mathematical procedure. It also includes the various characteristics and the numbers of parameters which are very flexible and which are actually predefined in nature. And that's why these models are actually called distribution-free models. Let's talk about the advantages of non-parametric test. It is very easy to understand. There is a procedure that we need to follow, and while following the procedure, we need to calculate the value of chi-square, the value of median, what would be the hypothesis testing to be processed, how it could be developed, right? That is comes under the non-parametric test, and that's why it is very easy to understand. Next one is its short calculations. So when we talk about the short calculations, so automatically there is no lengthy process to be followed under non-parametric test. It's a small procedure, small process, a short calculations is to be needed to exactly calculate the value of mean or median or the hypothesis testing values, and what would be the outcome based on that values. And that's why there is a short calculations which is the one of the advantage of the non-parametric test. As I told, that non-parametric test or under the non-parametric test, there is no rule of any assumptions. And that's why the assumption of any distribution like normal distribution, Poisson distribution, or binomial distribution is not required. It is applicable to all type of data, whether it would be a discrete data, it could be a continuous data, or it could be, you can say, the individual data as well. Disadvantages of non-parametric test: it is a less efficient as compared to parametric test. So automatically such non-parametric tests are less efficient. It couldn't be give a, you can say, a meaningful results as compared to the parametric test. So that's why it is also one of the advantage of non-parametric test. The results may or may not provide an accurate answers because they are distribution free. So when we talk about the parametric test, which involves normal, Poisson, and binomial distribution models, but non-parametric does not belong to any such models. And that's why the results that we get using these tests may or may not provide the accurate results. So that's why it is also the one of the disadvantage of non-parametric test. Next, we can talk about the applications of the non-parametric test. when parametric tests are not satisfied. So when we talk about when the any of the parametric tests like Z test, T test, and such tests, basically, when the results are not satisfied, then the non-parametric test will be applied. When any of the testing of hypothesis, that any assumptive statement, any fact, any declarative statement are need to be tested, it doesn't have any distributions or any distribution models like normal, binomial, Poisson. So automatically there is no need. So when there is no need to apply for a distribution models, then we can apply non-parametric test. It is these tests are very quick data analysis. So and using this test, a data analysis process would be very faster, would be very quick, so that the easily the answer or the results could be came out. Next, when the unscaled data is available, so when there is no scaling of data is applicable or available, then automatically we can apply the non-parametric tests. Now, these are the methods that the following test is to be applied, and these all tests are actually called non-parametric tests. So the first one is one sample sign test. Second one is chi-squared test. Third one is the median test. Fourth one is a min whitening U test. Fifth one is a Wolfscon matched pair sign rank test. And the last one is Krukel-Wallis test. So let's begin one by one the overview with the help of the numerical examples to study these tests. So the first one is one sample sign test. The one sample sign test is a statistical test which is mainly used to determine whether there is any statistically significant differences between the two groups or not. This test is one of the statistical tool which is mainly used whether the two samples are significantly different or not. It can be used to compare the two means, two proportions, two variances, or the two medians as well. The one sample sign test is a non-parametric test which does not require the data to be normally distributed. So it doesn't apply in a distribution models. How such test works? So it works by calculating the difference between the two means or median, then divide by the standard deviation. So if the absolute value of the Z score is greater than the 2.58, that means the null hypothesis is rejected and the difference is considered as significant at the P, that is the probability value, which is less than 0.05 level. Assumptions of the one sample sign test: data is non-normally distributed. The random sample of independent measurement for the population with unknown media. It means that any of the samples who having an independent measurements, who having an independent numerical figures for the population with the unknown media, that's become one of the assumption. The variable of interest is continuous series, and the one sample test handle a non-symmetric data set where there is, you can say, the non-skewedness of the data at the right or left will not applicable. Now we can come on to the one sample test t-test hypothesis. The one sample t-test has the following hypothesis, the two main hypotheses. The first one is null hypothesis, where the population mean is equal to the hypothesized value. Alternate hypothesis, where the population mean does not equal to the hypothesized value. So if the p-value is less than your significance value, that is 0.05, you can reject the null hypothesis. If the p-value is more than your significance value, that is 0.05, you can accept the null hypothesis. That means the difference between the sample mean and the hypothesized value is statistically significant. So your sample provides strong enough evidence to conclude that population mean does not equal to the hypothesized value. And this is all about the result of the t-test. One sample t-test hypothesis results. So if any of the p-value is less than the significance value, that is 0.05, you can reject the null hypothesis. Otherwise, you can accept the null hypothesis. Let's take about the example of the one sample sign test. A Bank of America West Palm Beach, Florida branch manager shows that the median number of savings account customer per day is 64. A clerk from the same branch claims that it was more than 64. That means the savings account customer per day is 64, but the clerk from the same branch claimed that it's more than 64. The clerk found the number of savings account customer per day data for 10 random days. Can we reject the branch manager claim at a 0.05 significance level? That means in the question, the significance level is 0.05. That means if any of the p-value is less than this value, then automatically we can reject the null hypothesis. That means the statistical results are significant. But in this question, the significant level is given. We need to calculate the p-value through this test, and the question is already given. The D's are 1 to 10, and the customer's values is already given 60, 66, 65, 70, 68, 72, 46, 76, 77, 75. So this is a question of the one sample sign test. So the first step is to just formulate the hypothesis. The null hypothesis means that the clerk has claimed that the particular customer per day is more than 64. So automatically null hypothesis means that the saving account customer median is equal to 64, and the alternate hypothesis is saving account customer median is more than 64. So automatically the next step is we have to assign the minus and positive sign in the particular days according to the values of the customer per day. So assign observations less than 64 with a minus sign, and assign observation above 64 with a positive sign. So automatically when we talk about the first is 60 is less than 64, it's minus. 66 is more than 64 plus. 65, it is more than 64 plus. 70 is more than 64 plus. 60 is more than 64 plus. 70 more than 64 plus. 46 is less than 64 minus. 76 is more than 64 plus. 77 is more than 64 plus. 75 is more than 64 plus. So when you formulate the hypothesis based on the question, then automatically the next step is to assign the observation with the minus and the positive sign, which has been done in this particular solution. Then the next step is to calculate the total number of positive sign and the total number of negative sign. So the total number of positive sign is 8, as you can see in the table, and the total number of minus value is 2. So when we talk about the which value is minimum out of 8 and 2, the value is 2, which is equal to 2. Now we can look up after this the binomial table that in order to test the results, in order to estimate the p-value, we need to look up the binomial table which observe the number of observation, the total number of observation is 10 and the minimum sign value of 8 and 2 is 2. So automatically, as we can have a significance level that is 10 into zero point 0.5. So just have a look where the 10 is the total number of trial or the total number of days, and zero point 0.5, that means is a significance level, that means a 50% chances the value, it could be a more than 64 or could be the less than 64. So automatically that's called the significance level, that is 0.50. Now, this is a binomial distribution table. If you look up the binomial distribution table where the n is given the 5 and the x is a series of 1 to 10, and these are the significance level, that is 0.05, 0.10, 0.15, 0.20, and so on till 50. So automatically, as we can see, the significance level is 0.50, where the probability, 50% chances of the probability could be the positive or could be the negative. So automatically it's 0.50. So as you can see, the 10, that means if you look up the question, if you look up the solution that we need, look at the binomial table, that is 10 into 0.05. So automatically we can look up the 10, that is n is a number of trials or the number of observation, total number of observation is 10, then automatically if you look up the 0.50, what would be the values is 0.001 and 0.011, that we can see that both these values are less than the significance value, that is 0.05. So we need to check on the results, that what would be the rules of this particular test is, if any p-value is less than the particular, you can say the significance level, that is 0.05, then automatically we have to reject the null hypothesis. As you can see, there are 10 number of trials, that is, and automatically what would be the values of x, that is 1 to 10. So if you look up that 0, 1, which is less than the 0.05 significance level, and rest of the x values of 2 to 10, which is more than the 0.05. So automatically we can conclude that at 0.05 significance level, the probability for x, that is, as you can see, the minimum value of the minus and negative sign is 2. So automatically the probability, we need to check on the value of the probability of x is 2 only, which is, you can see in the table, that is 0.055, which is greater than the significance level, that is 0.05. As a result, it comes under the acceptance reason. That means if any p-value, that means that is 0.055, which is greater than the 0.05, that means we have to accept the null hypothesis. Or in other words, we could say it's failed to reject the null hypothesis. If any of the statements says it's failed to reject the null hypothesis, or in other words, we accept the null hypothesis, the outcome would be, that is, there is no significant evidence that the number of savings account customers per day is more than 64. As the clerk has already claimed that the number of customer per day is more than 64. That means the median is more than 64. So automatically we have to state that whether it is more than 64 or not. So automatically based on the binomial distribution table, the probability for x2. So as we have already estimated the x2, that is test statistics, is a minimum of a positive and negative sign, that is 2. So the minimum sign is 2. So automatically we need to estimate the value of x at 0.50. So automatically the value would be the binomial table value is 0.055, which is greater than the 0.05. As a result, we have to accept the null hypothesis. That means there is no significant evidence that states that the saving account customer per day is more than 64. And that is the conclusion of this particular result or question. So if you look up the question over here, it is mentioned that shows the median number of saving account customer per day 64, and the clerk is claimed that it's more than 64. So we need to prove that whether we have to accept the branch manager claim or reject. So automatically we reject this claim. That means there is no strong evidence or significant evidence which reveals that the saving account customer per day is more than 64. So this is how we solve the question. We have to formulate the hypothesis based on the question. Then we have to check on the positive and negative sign. Then we have to check on that which is the minimum value of from the negative and the positive numbers. Then automatically we get 2 over here. Then we look up the binomial table of the total number of observation and the 0.50, you can say probability values, then automatically, which is a 0.50. So if you look up the binomial table, we have checked 0.50, the value of 2 is 0.055, and automatically when it is more than the significance level which is mentioned in the question, that is 0.05, the result is we have to accept the null hypothesis, or in other words, we failed to reject the null hypothesis. So automatically there is no significant evidence that states the number of saving account customers per day is more than 64. So this is how this particular question will be solved using the one sample test which has been shown over here. So let's begin with another test that is called the chi-square test. The Pearson chi-square test is a statistical test which is mainly used in a categorical data. So when there is a data which has been categorized, then such test will be applied like A, B, C, D, E, F. So if in these form the data has been given, we have to apply the chi-square test. It is mainly used to determine whether your data is significantly different what you have expected. So there are two main types of Pearson chi-square test. The first one is chi-square goodness of fit test and the chi-square test for independence. So when we talk about the chi-square goodness of fit test, is used to test whether the frequency distribution of any of the category variable like age, we can talk about gender, we can talk about the income level, which is actually different from our expectations or not. In that particular sense, we can use the chi-square goodness of fit test. The next you can see type of chi-square test is chi-square test of independence. It is mainly used to test whether two categorical variables are interrelated to each other or not. So if we need to find out a relation of both of the variables, whether the one variable is related to the another variable, then the chi-square test of independence will be applied. Chi-square test is written as chi-square and is pronounced chi-square, that is I square. It is also called a chi-squared. Pearson chi-square test is also called the chi-square test, which is almost one of the most popular tests under the non-parametric test. Non-parametric tests are always used for a data. It does not follow any assumptions at all. If any of the hypotheses to be tested using the categorical value, you will always need to use the chi-square test, which is also the another version of the non-parametric test. So chi-square test formula, which has been shown over here, that is chi-square is equal to sigma OI minus EI whole square by E, that is expected value, O is the observed value. So C is a degree of freedom, O is the observed value, E is the expected value. The degree of freedom in the statistical calculation represent the number of variables that actually varies. So the degree of freedom can be calculated to ensure the chi-square tests are statistically valid or not. So the observed value, what are the observed and expected values? Observed values are those that you gather yourself, which is always available. But expected value, it's need to be calculated, and it will always be based on the observed frequencies, which could be considered by me preparing or formulating the null hypothesis. So let's have a question. As per the survey on cars owned by each family in the locality, the data has been arranged in the following table. Now you need to calculate the chi-square value. The number of cars is already given, that is 1 car, 2 car, 3 cars, and the observed frequency is 30, 14, 6, and the expected frequency is 25.6, 15, 5.2, and the total, that is grand total, is of the observed frequency is 50. So how to estimate the chi-square value, that we need to learn through this question. So automatically we have an observed frequency, we have an expected frequency, we also have a number of cars. So automatically, as per the formula, if you look up the formula, we need sigma O minus E whole square by E. So automatically, when we come up to the solution, we need O minus E whole square. So automatically, when we talk about the O minus E, so we get, and when whatever the value that we get and we square, that is 19.36. So when we talk about the values, so automatically whatever the value could come, we need to square that value. Same in case of 14 minus 15. So automatically the value would be 1.216. You can say minus 5.2. The value could be the 0.04. So once we calculate the O minus E whole square, the next step is to divide the expected frequency. So the expected frequency is mentioned in the question. So we just divide O minus E whole square by the expected frequency, and we get the value of chi-square. Individual chi-square value we get it, that is 0.645, 0.086, 0.106. So once we get all of the three values, we add it, that is 0.837, and this value is called the chi-square value. So in the question, it is given the observed frequency and expected frequency. We just minus both of the frequencies and just square that frequency. We will get the O minus E whole square value. So when we divide all of the values by the expected frequency, we get the individual chi-square value. So when we add on all the individual chi-square value, we will get the grand total of the chi-square value, that is sigma O minus E whole square by E, that is 0.8, that is 0.834, and this value is called the chi-square value. We can also look up the another version of the question using the chi-square test based on the rows and columns. So this is a question that which pet will you prefer using the chi-square test. So the cat and dog is already mentioned in the columns, and then the rows men and women, and the values is already given. That is 0207, 282, 231, 242. So we can look up, we need to calculate in this question the observed and expected. So the frequency which has been looked by yourself, that is the observed frequency. So in the question, we have a values, we have a frequencies which has been given, and that frequencies are called the observed frequency. So the next step is to calculate the expected frequency. So we need to learn how to calculate the expected frequencies. So this is a question. Now the next step is to total it. You have to total the columns. You have to total the rows as well. So the question is cat and dog. The observed frequencies are given between men and women, and you have to total of each row and each column. So the total of each row is 489 and 473, and the total of each column of cat and dog, that is 438 and 524, and the grand total of all rows and columns, combination of row and column, is 986. That means the total of men and women and the total of cat and dog would remains equal, and when the any value it remains equal of the row and column, that becomes the grand total. That means 962 is a grand total. Now the next step is to calculate the expected frequency in the chi-square test. So what is the formula of expected frequency, which is equal to the row total into column total by grand total? So as you just add up the all rows and columns, now the next step is to calculate the expected frequency, and the formula is already given to you, that is row total into column total by grand total. So when we talk about the expected frequency of first row and first column, so we can talk about the first row is men, the total is 489, and the first column is cat, and the total of cat is 438. So accordingly, we need to calculate the expected frequency of first row and first column. So automatically, which is equal, the formula is row total. So what would be the row total of first row and first column? That is 489 into column total is 438 by grand total is 962. And once we multiply and divide, we will get the value of expected frequency of first row and first column, that is 222.64. Now we need to calculate the expected frequency, already estimated the expected frequency of first row, first column. Now we need to calculate the expected frequency of first row and second column. And so on, we also need to calculate the expected frequency of second row, first column, and again the expected frequency of second row, second column. So as in this question, the expected frequency of first row and the second column, the total of first row is 489 and the total of column is 524, and the grand total will remains the same, 962. So for the expected frequency of first row and second column, that is first row, the total is 489 into 534, the total of column of the second column, in divide by grand total, that is 962. So once we multiply and divide by the grand total, we will get 266.36. Now we need to calculate the expected frequency of second row first column. So what would be the total of second row, that is women's, 473, and the column total of the first column is 438. So 43, the expected frequency of second row first column is equal to the row total, that is 473, into column total, that is 438, by grand total, that is 962. So whatever the value could estimated, that value will call the expected frequency of second row first column. Now again, we need to calculate the expected frequency of second row and second column, that is 473 into 524 by grand total 962. So now in the next slide, we will look on the expected frequencies. So now you need to calculate the expected frequency for each entry, and these are the expected frequency. For the men, we have estimated 222.64 expected frequency, and for the second column of men, we have estimated the 266.36, and we have put these values into the table. So we look up to the men, the expected frequencies 22.64 and 266.64. And when we talk about the second row first column, that is 215.36, and second row second column, that is 257.64. These are all expected frequency, and the total will remains the same, which is given in the previous slide. So this is the calculation of the value of chi-square. We have an observed frequency, we have an expected frequency. We just minus and square and divide by expected frequency. So these are the calculations. We subtract this expected from actual, that is observed frequency, then square it, then divide by expected frequency to estimate the chi-square value. And in this table, we have shown that how it has been deducted, square it, and divide by expected frequencies. So once we do follow this procedure, we have calculated the chi-square values individually. Also, when we added the chi-square value is 1.099 plus 0.918 plus 1.136 plus 0.949, which is equal to 4.102, and this is called the total chi-square value, or sigma's chi-square value is 4.102. That means these two variables, cat and dog, are not independent at all, which relates to men and women. So that's it for today. Thank you for listening this lecture that we have covered the two main important tests in today's session, that is the chi-square test and the one sample one sample sign test. So that's it for today. Thank you for listening this lecture. Till time, thank you and namaste to all.